Hoppa, hoppa. Hello everyone, not salut tout le monde. So welcome to this first class. I'll wait for people a bit to come before starting, and to get in the headspace of speaking English instead of French. See the yeah. Hello Miwi, hello team. Yeah. So I hope you guys are going to enjoy this one. Hello Darius. Yeah. Since I've done like the first two classes already in French, the one 2 weeks ago and one this morning, seems to go well. I'll see also how many people are coming for the English one as opposed to the French one. That's gonna be interesting. But yeah, because usually like I'm gonna tell that again when I start, but I usually do that class as part of at the university in person. So usually there were at the beginning of the year we were like 30 people, 35. We started in September or October when the classes actually start, and and that means you get a lot of people at the beginning of the year, but it tends to dwindle down as time goes on, and the part that kills momentum for a lot of people is the winter leave, with Christmas and the New Year, and then it's like a lot less people between 3 and 6. So we'll see how doing it later in the year and doing that online will change things. So yeah, what's also gonna be fun is that usually I do that with the Computer Science Association at my university. Therefore, it tends to, it tends to be seen by a lot of students. Here, it's more like my online clout. Let's say it like that. So it's also a bit of a. It's not gonna reach the same people, of course. Yeah. But in theory, you guys already have the benefit of me having done this a few times. So a bunch of the issues that were at first are now gone in theory. Yeah. Just to check the latency, I'm gonna say ping. You guys are gonna answer ping. Maybe I didn't give a lot of warning beforehand. So are you guys hearing me okay? All of that good? So I can adjust it before it starts. Perfect. Let me. So I'm seeing if there's gonna start in 3 minutes. I think the time for the few remaining people to come. If they want to. Checking all of that again. Sure. But yeah. So let's. So everybody having a good weekend for now? On my end, it's been quite chill in general. been playing a bit of the new Yakuza. Yeah. I hope you. Is it not? I mean, what time is it at your in your country right now? In mine, it's 15 o'clock. So early afternoon. Can I chill? Yeah, I don't know if some people woke up like at at the early times just to watch that, or in the opposite end, stayed up late. Yeah. Gonna gonna show the slides so that we're going to be starting in 55 seconds. I see the timer. Yeah. Yeah, well, each in its own time. Like even your limitations are going to be. Your limitations are also going to be able to give you your own voice in some ways. So don't worry about it. Just do what you feel is right. And you're in Asia. That's well, I have a friend that lives in Asia too. But yeah, it's sometimes it's a bit tricky to talk. Yeah, well, wait, if it's what time? If even if there's 9 hours of difference. Oh yeah, so that will be late. Hope I don't put you to sleep, but yeah. Okay, well, with that, let's start. So welcome everyone. Thank you for coming to my game development class. So, I'm Panayotis Tsiapkolis, also known as Panthavma online, and so this is gonna be just an introduction of the class to get a feel for things. That. So let's talk a bit about that. So first of all, who am I to teach you all of that? So I'm currently a computer graphics researcher at Ubisoft and the INRIA Bordeaux, which is a research lab. And I'm currently doing a PhD in real-time stylized 3D rendering with a focus on artistic control. So before starting that, I did work at Ubisoft on Rainbow Six Extraction from 2020-2021. And before that, for my studies, I did a computer graphics masters at the University of Bordeaux, computer graphics and sounds more specifically. Very good. And I spent my licence 3. So it's in the French system. It's the third year of university, where the master is the fifth. And so I spent it at Irvine in California, at UCI. And I studied computer science there with a focus on video games, since there was Blizzard and Riot nearby. And but I started programming a lot earlier in 2004, so that's about 20 years now, dang. And with I started video games a fair bit later in 2009. So some of the things I've worked on you might have seen or played. It's so in AAA, Rainbow Six Extraction, where I did some 3D programming. I mostly worked in the shadows, and I mean that literally, because I optimized the ambient occlusion, so the shadows in the corners, and the shadows on the gun. The shadows on which the first-person model self shadows, which is a mouthful, but basically the gun. The shadows that are made by the gun and also shown on the gun were programmed by me. And also, and after that, I worked on the Xbox port a bit, so mostly trying to test the online and the streaming installation procedures. In terms of indie development, you might have seen Chrono Titans, and I guess most people in the chat have already seen that. Yeah, Chrono Titans, which is a 2.5D fighting game, and in terms of open source, Castime, which is a tool for said fighting game creation. And in terms of rendering, the most recent example I found is the watercolor algorithm I made, which was an adaptation and modification of some of the state-of-the-art algorithms from Montes de Oca. Uh, and hopefully I'll be able to put to update that slide soon with my PhD work. But this class is gonna be in two parts, two main parts. So the first part is gonna be about covering which is gonna be the main one, is going to covering every one of the main subjects I found, which are programming, design, and aesthetics. And I mean that in more etymological sense of the word, which is based on feelings, so art and sound here. So the classes I'll be teaching are going to be, in terms of programming, I'm going to talk about gameplay programming, so how to actually make the game mechanics. I'm going to talk about tools programming and the logic behind that, so a bit of UX too. And I'm going to talk about code architecture, you can organize your code to be able to work efficiently and not end up with a plate of spaghetti. I'm gonna talk about design, so game design is gonna be more philosophical. The first one is gonna be on the mechanics and feelings, different ways of approaching the idea of a game. I'm gonna talk about project management, because most of the time the designer is also going to have to make some of that, and how to handle your project, how to scope, all that. And I'm gonna finish with communications and decisions. So that will be covering both the player to game communication and game to player communication, and how to balance decisions a bit, what kind of logic is there. And in terms of aesthetics, it's a bit more straightforward. I'll be talking about 2D and 3D first, but only static 2D and 3D. Then we're gonna talk about how to animate it and how to do VFX. And then we're gonna take a look at sound design and music. So that's the first part, and after that you should be able to have a good basis for that. While the second part is gonna focus on some more advanced subjects, so shaders, online programming, engine tools. So in this case we have 3 classes for now on that. It's one on online and netcode, so because I know a lot of people are coming from fighting games, so it's also gonna cover rollback, of course, which is a type of lockstep networking, but also more of the not predictive but divergent networking. And I'm gonna talk about 3D rendering, and with this one is gonna be 2 classes actually, one on general 3D rendering for games and one on stylized rendering, because as you know that's my specialty, so I gotta share on that. So, but you can suggest topics you like, of course, and that's an open part. And by the way, as I'm saying, so for this class, you're not in person, so you don't really see that, but it's very open. You can even if I kind of like a discussion type format, especially when it was in game design. So that means don't hesitate to post in the chat during the class, because that way I can see it, I can react and talk to you guys about what's going on. I can answer questions in the middle. When I did that in person, I told people to interrupt me if they wanted to get more detail on something. So you are free to do that, and so you can see, of course, in the overlay we also have the links to the Discord. So don't hesitate, even if you miss the class and have to do a replay. All replays are going to be available, of course. Don't hesitate to pop on Discord to ask some questions. So yeah, so how to benefit from this class. So as you've seen, I'm going to touch upon a lot of topics in a very short time span. So so instead of being able to follow everything that you do one by one, I'm not going to be able to teach you the actual practical skills in detail. Like once you come out of this, I'm not gonna be teaching you, you have to put these types of lines of code one after another, or okay, so you have to draw like this. No, that's we don't have enough time for that. This class is gonna be more focusing on giving you the keys for understanding and practicing. That means instead of at the end of this class you won't know the skill exactly, but you will know how to learn this skill and how to talk with other people that have this skill, because this is the interesting part, because game development is very collaborative, and it's from very different fields that each require a very specialized skill set. Where, for instance, here I am a 3D programmer. Like, what do? I write the code that allows what the artists do to show up on screen. And this is one of the you require a lot of very specialized knowledge for that. So that's why it's only a master's, and that's why a lot of people are actually scared of going into graphics code. But I don't know, that doesn't mean I have like people that did all of that and focused their studies on that, didn't focus their studies on art. But with this, you will have the keys to understand, okay, what are the art people looking for, to do, what are the points of contact. And that means you can interface with them and collaborate and communicate in general. So this year, so it's recorded and in English. So because basically, so this class is actually the third year I'm giving it. So I've started with as I said, I'm currently in my third year of PhD. Just started, but this is the third year also of the class, because I started this class a bit before the PhD because I had a bit of time. So I went to the Computer Science Association at the University of Bordeaux in France, and we did the well, it just went in. It was an after school class we did on the university itself, and I made the program. I taught the class for 1 year. Then I did it the second time. I a bit more involved. You know, I made it evolve with the first few feedback. And but this year, you know, with getting in the final year and a lot of things going faster, I don't really necessarily have the time or commitment to be able to do that every week in person anymore. But I already have all those slides, and it was also limited only to the people that did come at the time. So it was a bit sad. So I said, yeah, let's do that again this time online. That's why I'm actually doing it both in French and in English this time, so you guys can also enjoy it. That's why also, if you know French, you can actually go a bit quicker, because I have the previous slides already. I do that. I do the French class in the morning and the English class in the afternoon, and the English class is actually 2 weeks late compared to the French one. Like it's only one. But yeah, I talk about that a bit later. But yeah, so you might have noticed I also write a lot of words on the slides. So it's on purpose. It's not because I have to remember what I want to say. It's because I figured, like, if you have the main points on the slides, you can refer to them separately and quickly when you need it. You don't need to rewatch the whole recording of this video. You can watch the 30 slides here and quickly zero in on what part you wanted to. And if you want more detail, well, you can watch the recording once again. So, and one of the things I have from time to time, when I don't forget to add it, I have some question slides here where you can actually answer as you want. And this questions right now is going to be, what is your skill level? So how do you feel about that? Are you a beginner, intermediate? Do you have 50 years in AAA already? You know, so feel free to jump on your keyboard to answer. And fair bit for this first class. There's quite a few of these, so I can gauge a bit what kind of people are there. Okay. You're a beginner, okay. Intermediate computer science, beginner game dev, yeah. Intermediate programmer. Oh, that's nice, because one of the part I skipped over is that this was with the Computer Science Association. So for the people that were in computer science, therefore there's a bit of a computer science focus on that, especially in terms of programming. Like, especially when you're gonna see the next class, it's gonna be easier if you already know a bit of programming, because I'm not gonna explain all the basics. I'm gonna explain some of the logic, but it might be a bit rough. So yeah, MIUI bachelor in game design, but barely any practical experience in game dev graphics. Yeah, I did a few game design classes at when I was in Irvine. Yeah, it's a really different point. Especially like I said this morning to the other class, but the one thing I feel, especially for game design, is kind of like how an artist, can have a vision, can have the idea, the theory, and then there's also the technical part with the pencil. I think that's kind of the relationship that programming has to game design. Like, you can have a vision, you can have the theory, but you have to explain your mechanics in detail, and that's where programming comes in. Taking a lot of computer science classes, but very little experience. Well, that's always a nice point to start. But yeah, okay, I see. So in terms of this class, so you don't need to have all of those skills to begin. So I assume you might have never done any of this before. So for beginners specifically, I'll give a few keys and how to start, with the software. But the best would also be to learn those skills on the side. Like at the end of the classes, for instance, programming classes, I'm gonna say, okay, so you can do. I'm gonna give you not assignments, but I'm gonna give you like what sort of stuff you can do on the side if you want to go further. The slides here aim to help you from beginner, complete beginner to intermediate. So I'm gonna talk about the concepts that you're gonna be building towards as you're learning. So I recommend you make a small game alongside the class if you can, but that's not mandatory, and I give a bit more detail at the end, as you can see on the program at the top. And so you can follow this class. So on my Discord, so in channel Gamedev class ENFR. So it's the link is on the overlay. The site for the class is panthavma.com/gamedevclass, which has the slides and the resources. Like if I have a link to share, I'll also put it there. You can also find the links for all those videos. So that's which I tend to try to make the links when I can and upload the slides a bit in advance. Like you already have the slides for this class right now if you want to follow them on your own computer. So when does the class happen? The class happens every other Sunday. That's not always gonna be exact. Like I don't know exactly my planning that much in advance, especially with PhD. Sometimes you have to travel, especially with the vacation time I've gotten this year. To be honest, but yes, so it's gonna be around every other Sunday. So I try to. I always will give you when the next class is at the end of one of these. So you can try to check the plannings a couple of weeks in advance usually. Like I know the next class is also written on the overlay, but next class is on March 3rd, so in 2 weeks. It's always at 15 Paris time. So I think it's CET, so you can check on your own time zone. If you're not able to make it, you can check the replay later and ask questions on Discord. So and I'll try to answer, or other people can try to answer. That also works. But yeah, so let's get into the meat of things. So how is a game made? Oh, by the way, the classes are between. The time it takes for one class depends a bit. It's so it tends to stay between 1 hour and a half and 2 hours. Depends a bit on the class. The rendering class was 2 hours of me talking non-stop, but some of the game design ones, for instance, were shorter. But yeah, so how is a game made? So let's start with a question. What are the elements of a game? That's a bit of an open question. There's not necessarily wrong answers, because there's a lot of ways to look at a game. That's a trap question I'm seeing. Like there's not other people answering. There's no trap on that. Huh? It's because I've had answers in very different directions. I don't know if it's the thing. A system that can be interacted with. So that one, that's a definition for a game. That's the wrong class. This is for the game design class. That we're going to be asking questions like what is a game. I don't see other answers at the moment. So let's get to another one. So what are some of the elements of a game? So you have several ways to look at it. You can look at it like, so there's the story, there's the art style of that. But I'm gonna take a look at a more practical way, a more bottom-up way, which is gonna be you have the engine, which is gonna be the tools that are used to make the game and generic algorithms that go with it. You're gonna have the code, like the gameplay code, which is more of the logic and the mechanics how they're made. You're gonna have the assets, which are gonna be graphics and sounds, usually. And you have the data, which is gonna be more about configuration and balancing. And you can usually fit things into one of those categories. It's not exhaustive, it's only one view, as I said, like saying like the writing, the art style are elements of a game is also valid. It's more of a top-down approach. It's one more bottom-up. Levels can go in the side of assets or data. It's a bit more data than that. But yeah. Next question, especially. So, who works on a game? Also, general answers. You can. I'm not looking for if there's right or wrong usually with these questions. It's gonna be easier. Someday I might try to use like those YouTube surveys if I don't do open questions. That's so it might be a bit easier to answer. Don't feel bad about writing something that you might feel incorrect. The more mistakes you make, the faster you learn. That's the thing. Yeah, game developers. Yeah, you should have worded that better when I translated it yesterday. But yeah, artists and programmers. Yeah, this kind of works better in person. Creative people. Yeah, that's not all of the time. Not all of the time. It's but you have a lot of them. Yeah, but you have some people that are more on the very rigid side, but it's not. It happens more in bigger studios because you have a lot more leeway. Like just as a small aside, for instance, when I went at Ubisoft, you could see also like not everyone had the same experience with games. Like I'm a big gamer, but and I was in the engine team, but the engine team was kinda split half and half, you know. Most people, everyone had played games, but about half of them were still playing, and the other half were playing from time to time. You know, a game of FIFA with friends, if you happen there. If there's a World of Warcraft extension coming out, where for all time's sake they open it again, while other people were very, very, very good inside of the esports and stuff like that. People in more the gameplay programming team and game design were all big gamers, but you have also some people on the more back-end side, for instance, of the servers, which are like, oh yeah, well, I discovered games a lot through this job instead of through coming in here before with gaming experience. So that depends also on the size and what field exactly you do. Yeah. So I'm gonna take a bit of a tour of different jobs that are in games. So it's so I also compare them into those three pillars, which I said before. So programming, design, and aesthetics. And to that I add a fourth category for support roles. With the idea that support roles are still part of the team and needed for development, but they don't act on the game itself, they act on the team, if you can see what I mean. But yeah, you can in general associate one job to one of the categories, but some may span several categories. For instance, the tech game designer, which is a game designer that also knows how to program and thus gets a job, or the tech artist, which is an artist that isn't scared off by code or at least nodes. It's a bit of a those tech jobs have a bit of a wide range. Like it depends from studio to studio. By the way, like some people say I can be considered a tech artist with my stylized rendering stuff, but it's a bit further. It's a different approach. So each of these fields requires different skills, and they must collaborate to make the game, which is why it's important to know what the others are doing and what the others are looking for, especially. That way you can know what parts of your job they're interested in, and therefore how you two can help each other. So the idea here is not to tell you, so these are the exact jobs you'll find. So no, that changes depending on studio, that changes depending on team size. Especially if you are in small teams, you're gonna have to wear a lot of hats, I say. So the idea of this is not exactly to give you a rigid view. It's more to give you, okay, so through those jobs, that means that you have some people that have to do that, some people that have to do that. You can have the same person for everything, and that way you can also see some jobs that you might have not thought of as jobs in games, and therefore that can help you get a better grip of what is going on, and maybe find a way for what you want to do later. So let's start with the design. So in this job family, so it's more to they define and refine the mechanics, so that means also the balancing and all that, but they also have to communicate them to their team, and that's a part that you often sometimes forget, and you have to do that through a lot of ways, through documents, through reunions. A lot of people talk about what they say the game design document, which if you don't make a lot of care, is gonna be like a very monolithic document that's very huge and nobody's gonna read. What you want to do instead is do more small documents and share them more often with your team. So some specialties in there, like you have two main ones. For instance, you have the systems designer, which usually tend to be more focused on mechanics. So for how the game loops, all of that. You have level designers, which are going to make the levels themselves. Like not the art, that's the environment artist or level artist that does that. Usually what the level designer focuses on is on the flow of the level, which is why they tend to use gray box, which are, well, gray boxes you put in the level to just block it out and find get the idea of the environment. Where do enemies spawn? How do players react when they talk to that? If you play the map like TF2 Orange, if it's not too much of a boomer reference, you have the whole map is pretty much gray box, even if there's orange ones there. You have other specialties. Those tend to depend a lot on the project. So you have for instance combat designers, which happen on very combat centric games. You have the technical designer, which, as we said, is a game designer that also knows how to program, and which is actually a very important job if you can have it. It's very useful because a technical designer can already try out his own mechanics in the game, so that means he can iterate on his own, which is very useful. He can also explain what he wants to do in terms for the programmers, and he can link the design team to the programming team, because sometimes designers don't have because programming also requires the programming logic and how to separate the exact mechanics. So the technical designer, because he can speak both languages, he can help translate that to the programmers themselves and get ahead. But of course, you can have other systems which are specific to the project. For instance, if your project is very based on economy and markets and stuff like that, you could have someone that's an economy designer or an economist even, if you read online. But yeah, so that can vary a lot. But you have to remember that communication is a big part of the job of design. You have programming, so this is who the people that have to implement the logic and the links needed for the game to work. So what happens when you press on a key? What happens? So you have two main categories here, which are the gameplay programmers, which are going to work on mechanics specific to the game, and you have the engine programmers, which are going to work on the underlying algorithms that go in there. which are more generic. So to give an idea of the difference, it's gonna be, for instance, if you have a platformer, you have a Mario, and so the gameplay part will be more like when you press the button, Mario can jump. When he hits his head on the block, he breaks it. If he falls on a Goomba, he kills it. This is more part of the gameplay programming side. The engine side is gonna be, how can I know if the button is pressed? How can I render Mario on the screen? Where do I display him? How do I know if he collided with something? This is the engine part. So you have a lot of specialties, of course, once again. On the engine side, you can have the 3D programmers, which is me, which is gonna be like how to render the Mario. Whereas which is usually a pretty separate specialty, like even in code, the graphics engines tend to be quite separate, because it's scary. So, and where general engine programmers work on a lot of different systems. You have a UI programmer, which is usually working with a UX degree on top of that, or someone who has one, who works with to create the user interface of the game. You have the tools programmer, who doesn't work on the game itself, but on the tools that are going to be used to make that. So the level editor, stuff like that. You may have an online programmer to implement the netcode and the parts that are more related to that. There's plenty of it to go around. And then in aesthetics, those are the people that are going to make the visual and audio elements. So of course, because it's a bit more of a wider category, there's gonna be more roles. So you can have, for instance, a 2D artist, which are going to draw the graphical elements. So for instance, the sprites, but also sometimes the UI, depending on how wide is your area of expertise. When you go into 3D, you have a bit more people. You have the modeler, for instance, who creates the 3D models, and depending on the project, he can also create the textures, for instance. Though sometimes it is given to another artist. You can have the animator, which is going to create animation from the models and the rigs. So a rig is a way to move a model like a puppet. You put a skeleton inside, and you can move it around. And on the sound side, the audio side, you have the sound designer, which is going to be the main role there, which is the one that is going to create and adjust the soundscape. And by that I mean the sound effects, the ambient sounds, when does the music play. Not necessarily make the music, but he's there to handle the audio side. So there, of course, it's a bit of a high-level view, because you have a lot of very specific jobs. For instance, within the modeler animator, you often have someone whose job is just to make the rigs, which is the rigger. You can have sometimes a texture or material artist. Usually someone makes the model, then someone makes the textures and materials for the model, then someone rigs the model, then you have the animator, you have the UI artist, as I said, you have the special effects artist or VFX artist, usually that does particle effects, for instance, which is sometimes the part of the technical artist, although I would say the technical artist is usually someone who does some shaders, which are programs that run on the GPU. So of course there's shader and shader, because you have simple shaders that are about like maybe changing the color of a sprite depending on what happens, and you have the shaders that are a bit like, let's compute the AI compute the AI on the GPU to go faster, or let's compute the light reflection going through this part. That's more on the programming side. Technical artist is gonna be more on that make shaders that change the color side, or that do other effects that are also pretty cool and sometimes technical. But it's a bit of a blurry line. Technical artists often do tools for the other ones. For instance, to make procedural modeling tools, sometimes help with the technical direction of the game. So yeah, they tend to support the other artists a lot. You have the composers that make the actual music itself. You may have writers if your game is very narrative driven, or narrative designers in general. You can have a lot of them depending on the exact scope of the project. And of course, if you're a small artist, sometimes you only have one and he does everything. Yeah, and then you have the the support jobs, which help and organize the teams during the project. So I'm gonna get two of them, by the way. So we have quality assistants or testers, which are going to be which are very important to the game because they find and document bugs. So this is quite a big job. So we'll talk about it a bit more next time. But the idea is that a QA can help you a lot because they tend to be a bit more rigorous at times, like and faster to find those said bugs. But the main job of a QA is once you find the bug, you find if you can reproduce it, reproduce it reliably and with which steps. Like, okay, so I went through a door and I had a graphical glitch, for instance. So and I was holding my rocket launcher and I was firing, I was jumping through it. So there can be a lot of things. That's just one occurrence. You find a bug, but now you have to redo it. Can I go through that door again and do I have the graphical glitch again? Yeah, okay, so that's in the same conditions, I have it every time. That means I have now my reproduction steps. So now I have to make them simpler. So you continue, like, okay, does the rocket launcher affect this? If I hold the assault rifle, do I have the glitch? If I'm not jumping, do I have the glitch? If I go through another door, do I have the glitch? And that way you can go quite in depth and you can see, like, yeah, so this glitch happens only when I go through this specific door. And at that point, the QA's job is a bit, he can't go a lot further. He can't fix the thing himself. So he then contacts the programmer. He says, okay, so yeah, we have a bug when you do these few steps. And the programmer sometimes, because he's able to see, like, with the few steps, he might be able to see which part in the code is going to be a problem. Or in this case, for instance, it's just this specific door. It can hint that this is a data problem. So that means it's going to have to look in the level editor. So QA can help a lot. And I worked with a few of them, and that was always quite useful. And as a side note, because on the other day on Twitter there was I did answer someone on that question, so might as well share it here too. Like, a lot of times you feel the games are coming out very buggy, so you might say you might want to have more people in QA, which of course you tend to want to have more people in QA when you can. But the thing is that there's also a problem of scale. If you have a few QA on your team, let's say the project is 2 years. So you have, let's say people are able to test the game 25 hours a week. So we're gonna take a figure of 46 weeks because of holidays and people in general working. So, and let's say for 2 years, that's with 20 people in QA, so that means you have a big project. That's about 46,000 hours of testing. So not on the final version, on all the versions. So that means some bugs are already out, so sort of that. But let's say the game comes out and it's a good success. It's a big success. So it's you have for instance don't know 50,000 players, and so they all launch the game together at launch. And you're like, oh, well, the thing is that in that 1 hour in the launch of the game, they already have made more testing. They have tested the game for 50,000 hours, which is more than all that QA did, that big QA team did in all of the 2 years for the project. So that's why a lot of the bugs can slip through. A lot of the bugs, sometimes you find them, but you either don't have the time to fix them, or it's you can't always reproduce them. But even a bug that's gonna be nightmarish to reproduce, like it only happens 1 out of 10 times in very specific conditions. Maybe it only affects 0.01% of people, but when it's 50,000 people, that affects. When it's 1 million people, it affects quite a bit of them actually. So that's something to keep in mind. You have producers, which are going to be able to more manage the budget and the timetable of the project. So these are the people that are gonna be saying, okay, when will you be finished with that? How much time does it take still? And these are going to be able to say, oh, the game won't be finished sometimes here. We might have to cut some parts. Which part are we going to cut? which parts are going to be blocking someone else, so you can try to anticipate that. So therefore, so if you do that job well, that means that all the other developers can work uninterrupted and always have the procedures you need. That's kind of what we call like glue work. That makes the team stick together, and it's often invisible, but it's very important. You have, of course, other specialties. For instance, in marketing, you can have a manager, intermediate manager if your team is pretty big. You can have a community manager, which is going to interface with the outside. Which, for information, we tend to do have people that do read what people post online and give a digest to the dev team. So the dev team usually listens to the people outside. Yeah. So that's kind of a bit of a full tour. So after I've talked to Ridolf with all of that, what kind of field that already interests you? Just here when I just explained it to you like this. Is there something that catches your eye, or more than the other, that you may want to do? Aesthetics? Yeah, well, programming is cool too, but I guess we already have a few programmers on the stream. Study and narrative a lot. Oh. That's nice. Maybe I'm taking the time of the questions to drink a lot of water. Programming and sound design. Oh, that's nice. Oh yeah, I forgot to say, but a lot of time the sound designer has to work with the programmer to put the triggers in. So that's something pretty cool. Yeah. Programming architecture and aesthetics. Yeah, that's nice. Like if you tend to like both programming and programming architecture is a bit more specific, usually a bit more not low level but different. But yeah, like maybe you should stick around for the graphics class, right? Because I mean that's kinda what we're gonna do. But yeah. So let's see. So we have a few so of course the game goes through a few phases of development as time goes on. So there's not it's not always this way or this straightforward. But I'm gonna use Rami Ismail, I think that's how it runs the definition, which is, I feel it's pretty standard. So you have the prototyping phase, which is gonna be when you're testing and exploring game concepts. So for instance, should I make this game? This is you want this to be fast and to iterate quickly so you can test more ideas, because you're gonna spend a lot of time on the next parts. One of them being the pre-production phase, which is when you prepare all your base technology and your project direction. So that's when you make what we call a vertical slice. So for instance, a full level or a full character for a fighting game, for instance. What you want to answer with this is, can I make this game? For instance, for a level or a character, the first one is gonna take a lot of time, because you're gonna have to make all the basic programming, the basic technology, the level editor, all of that. And find all the basic issues first of all. So it's gonna take some time. So, but then you have to usually when you do a vertical slice, you want to make a second level or a character at finished level quality, and this is the part that actually tells you how much time this takes, because once you finish the first one, you know what you found the errors. So the second one is gonna be a lot closer to real time estimation, which is gonna allow you to say, okay, well, it took me maybe 4 months to make the first level. It took me 1 month to make the second. Okay, I have still 6 months of development, so I can. So how much levels can I make in that time? And the answer is not 6. It's it's gonna be lesser if you want to have some time and not crunch at the end. But yeah. So then you have the production. Once you're out of pre-production, you've answered your questions. Should I make this game? Can I make this game? Well, no, you make the game. So that's the main part of the pipeline. So of course, it's not always the same people on each part. By the way, you tend to grow your team between each of them, and if you're on a bigger studio, of course. And then once you arrive at the end of the production, you do your content freeze when you say, okay, we don't add content, we're just doing bug fixes now, and then you get your build that's going to do what we call going gold, which is more of the which dates more to the epoch when we had to use physical discs all the time, which is still it's the build you're gonna send to Microsoft, to Sony, to Nintendo, to Steam, which is gonna be like your final build of sorts, and they're gonna validate it. They're gonna be like, okay, so this answers all of the required things. It's okay. You can release it that way. When you do that, your game has gone gold. And in the old times, you couldn't, you didn't have updates and all of that. So that was where it ended. Well, you had a few months then to when you fiddle your thumbs and wait for the game to come out. And because you couldn't change that build once it has gone gold, you don't change it. That's the concept. It's been tested. It's the one that can be printed on the discs. Therefore, that was the end of it. And sometimes you have in old games you might feel it's more stable, but that's because they cut a lot of content before going there. Now we have a bit more time, and so we have that's why we have the big day one patches. Actually, it's because between the time the game goes gold and the release, there's a few months. That's why people tend to work still in those months, and now they fix a lot of more bugs, so the game is more stable. If we can do that. And the thing is that it's always a bit of a risk, and now the games have a lot more restrictions. Have less restrictions, so that means there's also a lot more possibilities for which hardware is gonna turn on and all of that. So that's why you get a lot. You see more bugs, but overall that means we get a bit more complete games too with that, because we are able to fix them and update them as time goes on. And that's why the day one patch is big. It's because it's 3 months of work on the whole game to fix what we can. And then you have the post-launch support, which is gonna happen for most games now, not just game as a service, which is another kind of worms. Probably not what you're going here for. So the post-launch is how you're gonna follow the project after that. Continue marketing, continue to interact with the community. How you're gonna adjust to some balance patches or bug fixes, or maybe even some new content, maybe some events, all of that. And something you have to keep in mind here is that most of the time for the post-launch content, you have to start it before you're actually launching the game. When I was working on Rainbow Six, for instance, Extraction, the post-launch content was being made. A part of the post-launch content was being made alongside the game. So that means while we were also testing the basics of while we are testing the full game, we are also doing the modes that were going to come out 3 or 4 months after launch. That way they are ready. You don't, because it takes a lot of time to make stuff, especially when you get with a reduced team after the project is ended, and you don't have the support of the engine team that can come to help you fix some stuff there. So it's so you have to get a bit of a margin, and that way you can. So oftentimes it's not rare that games come out and have already content ready or almost ready for the game to stay alive after the project. Good example will be for instance, when you look at in fighting games, when you look at the Grand Blue launch, for instance, they already had Lucifer already in the game, of course, but I'm pretty sure they also have some of the characters ready or almost ready before that. Whereas if you take a look at Under Night, they probably don't. That's why they have 6 months of separation between when the game comes out and when the other characters comes out, because it takes a lot of time to make one. Yeah, so if you have if they are chaining a lot of content, if someone's chaining a lot of content, it's ready beforehand, or they have a few teams working on it separately. So yeah, next question. That's one a bit for you. So what's your objective for this class? So do you want to make a game? Are you just coming by curiosity just to learn a bit? Do you want to hear my French accent? Oh yeah, so go ahead. there's no wrong answers. You can say you can say I found the link on Twitter, just clicked and stayed as kept it as background noise. So that's not gonna be an issue either. Make your own game, but at least honestly, put together a better path and understanding of reasonable scope for solo dev work. Yeah, solo dev is its own beast. Also, like this is a. I think this class can help you a bit there too, because that way you can know which parts of the development are you looking for, and but the key I think to solo development is to both to develop your skills, but also to know your limits and work with them. For instance, one of my limits when I started when I was younger was that even if I knew a bit of 3D modeling, I was still limited in that part because that was not what I focused on at the time. I knew some programming. I did use Blender since 2004, but it wasn't my main thing, and I couldn't do textures. So that's when I figured I have to do to make the computer work for me. Also, that's how I got actually into stylized rendering. So with a few rough things at first, but once I got it, once I started really diving deeper into it, that's the same methods I used then to because I wasn't able, for instance, to use textures, and my drawing style I didn't know how to draw then. It kind of adapted. It's more geometrical, so that means my designs are also more based on geometrical detail rather than texture detail, for instance. And the same methods I had to use to get through that are actually the basis for my PhD now. So, and that's why now my games look and feel different, because they are really built around my own abilities. Like, I'm good at code architecture, I'm good at code in general, I know how to do graphics programming, and that changes what I can do in these other parts. I think that's main key, and to learn deeper. Well, that's a nice thing. So then there's the making a game alongside this class. So this is a bit more focused for students because this was in a computer science association. If you're an adult, you have other circumstances that vary a lot more. So you can still use the tips, but you have to apply them on your own situation. But before that, new question, more philosophical. Why do you want to make games? This one is more subjective, and it's your own answer. There's no right answer here. This is just your own. I think this is the last question. But yeah, I'm drinking a lot of water. Yeah. Don't know if it's it's a bit of a bigger question. What are the ideas about game design you want to explore and put into the world? That's a very nice reason. To convey my game ideas or story. Yeah, that's also a good answer. Yeah. Well, always enjoy video games. I have idea on what games I would want to play. Yeah, that's also a good one. It's sometimes you have by the way, you have some games you like to program and some games you like to play. That's it. Just like game development and game playing, it's two different skills. Sometimes it's not the same things you like each time. So sometimes both match and it's very good. Sometimes it's different, But the thing is to keep the enjoyment. I'm gonna give you my own answer, which of course is a bit more complete. I could, I was able to think about it beforehand, but I mean, it's just one possible answer. This is mine. I recommend you also think about that from time to time. Like, what do you want to make games? What do you like in that? It's always useful. For me, it's because it allows for deep creative expression since you're creating full worlds in general. So you can make a lot more subtle adjustments, like compared to. I mean, you can explore more the interactions and stuff like that. It makes me explore plenty of subjects in depth. Like I have to do some research on a lot of subjects and how things work, especially how things work in our actual real world, which is a way like to see how to learn more about the world through through interpretation. That's very good, or through the algorithms, because we in game development compared to, for instance, medical programming, uh, I am able to see a lot more things. Like there's not one correct answer. Like if I have to make an IRM machine or well, an IRM or an X-ray detector, capture. I don't remember exactly the name, but yeah. So there's different algorithms, but there's the same end goal, and the idea is how well you can do it. In game development, it's more of a you have it's more about what can I do to make the game fun. It's more artistic. So that means you have a lot of ways. Like you can make a game about pirates, for instance, and when you do that, maybe you have to focus a bit on more on how did they navigate, how does the water work, how does hydrodynamism work, stuff like that. Which is that's for one game. On the other one, you're going to space. Maybe you have to look at other things, or you're doing an historical setting. So it's always super interesting. It's also the cutting edge technology because because all of those subjects you have to be able to understand them enough to see where you can simplify them to be able to make them run in real time, and that's quite a demand. And it's usually like you have to work a lot at the low level sometimes if you want to do something that's really different. So that's also always super interesting. And then it's a field that makes use of a lot of the skills that I love to do. So mainly code architecture and graphics programming, of course, because games are very, very big, like very, very big code bases. So good code architecture is a must. And graphics programming mixes mathematics, it mixes low-level programming, it mixes and because I do stylus rendering, it also mixes a lot of creativity on how can you do something, and you have to make all of that work together in real time on the GPU. So that's always a lot of fun. And well, that's only one answer. That's why I do it. You can do it for your own reason. So how to do that if you are also studying? So my advice is to give priority to your studies, because that's when you actually doing it. That's the one that's actually going to give you a diploma and all of that. So the slides and recordings are not going anywhere. You can come in whenever you want to these classes, and you can reference the slide. It's always there. If you can do a bit every week, it's good. It's better to do that, do regular progress instead of big sessions. Of course, it's always to adapt to you if you prefer doing it all the way. Because the main thing is only to do it while it's interesting for you. I don't want this to be another part-time job for you. I don't want you to work a lot and to burn yourself out. It's you want to find the parts that are interesting and work on those. If it's a hobby, that's what the point is. If it's a job, well, maybe you have to be able to want to make the job. I would also recommend to aim for smaller projects, even if you do more of them in the end, because a smaller project, I mean, it's usually hard to when you start out to really know how to scope things. So, and everything is gonna be new. So even something like a Tetris is gonna teach you a lot, especially about finishing games, which is its own skill, if we say that it is. My recommendation, because I know I'm not that kind of person. I'll be honest, I'm not that kind of person. I don't do small projects. It doesn't work for me. One thing that can work is to aim for the minimum, the minimum viable product, as they say. So you try to look at each element And even if your game is not gonna be as great as you think, you say, okay, which are the most core elements for my game? Like, if you have Mario, for instance, the core element is gonna be jumping on levels. Do you need enemies? Not necessarily. Do you need the power-ups? No. The enemies are gonna be useful, sure, but yeah, start with just like the level, just platforming gauntlets. That's gonna be enough for starters. And when you do one level, and that's you want to have the game be in a state you can basically say, I'm done with it, I don't want to work on it anymore, and you release it then and there. That's perfect if you want, and that means you can also test it very early. And then you can iterate, you can add enemies, you can add the power-ups, you can add the more levels. That's good, but that means at any point you can say, okay, it's not fun for me anymore, I can stop there. And have something to show for it. Otherwise you end up like me and you have plenty of systems that are very advanced, and you have, like, for instance, a 20-player online first-person shooter that works with several weapons, and then you don't want to make the levels, so it just stays at that, so... Which was very fun to do. I don't regret it in the least. Yeah, you have to watch out also for your balance, because game dev is often a field of passion. So this should raise a lot of red flags for you, because it usually means you're gonna get exploited, and that's true. You're gonna get exploited most of the time. It's not it doesn't pay that well compared to other fields, but usually so you have to be extra careful of your work-life balance and work conditions. For instance, this week there was a strike at Ubisoft, just for that. So the thing is that if you're going too hard because you care about the game, so you want to work more, but if you go too hard, you will hate what you do in the end. You will burn out on it, and I think for something you do for fun, something you like, that's a bit sad for that. So yeah, I think you have to pace yourself. And if you don't want to work on something, it's okay to take a break. One time I did have that problem, because I was aiming to do smaller and smaller projects to finish one at one time when I was testing out indie dev, and therefore you had to. And at what point it was just a bit too much. I just didn't want to open my editor anymore, so I just took a break, and that break took 1 year. That happens. That's not a problem. When I came back, I had a much more healthier perspective on that. And I think you can do good games over the long term in bad conditions. Sure, you can work a bit more at one point, and the game is not gonna suffer that much. But if you are not able to take time for yourself, you're gonna stagnate, which also means your game won't be as good as you think it will be. And as time goes on, you will have less and less good decisions. And even if you look at it even if you ignore the part where you live a good life instead of just staying in front of the screen working when you don't want to, even what you want to do with that is gonna suffer. It's a lot more effective to take breaks and to pace yourself. And something you have to be careful of is that crunch culture is still very much alive. You should not fall into it. When you leave at 5 p.m, someone says, "Oh, you're taking your afternoon off," that's not the kind of things you're here for. If you take your vacations, it's important. So that way you can. You don't want to do like those extra hours, because especially once crunch culture is there, it's not just a crunch to be able to say. It's when you do a lot of additional hours for a long period of time, and it's usually not just the crunch part, but it's also the culture surrounding it, where you have this guilt for people that if I don't stay late, if I don't stay this Saturday, if I take my holiday off something, then the work I have to do is gonna fall on someone else. And the thing is, no, you just have to. You should organize yourself better. Like the project, it's often not in your hands, but you can very much say no a lot of times. And the thing is, especially because even with good intentions, if you do make extra hours from often and you don't tell anyone, people are gonna actually assume this is your normal working rhythm. And that means that if they say, oh, for instance, you do this task A in a week, and but you had to crunch to make it. So they're gonna, but they don't know that, so they're gonna say, okay, so task A takes a week to complete, So they're gonna say, okay, well, you have to do it 5 other times, and now you have to crunch 5 weeks if you want to keep up that rhythm. So even with normal intentions, that can happen. So that's why I say you have to be very careful, and especially you have to avoid doing, if you can, avoid doing extra hours to finish the game. You want to have something that you can say this is your gold build a lot earlier than you need to. Like if you can have it a couple months before, that's the best. Of course, depends on the project timeline, of course, but yeah. So how can we start after this part that was a bit more a downer? So how can we start? So if you like the design part, something you can do is to start with paper prototypes. So that works very well for turn-based games, of course. But you can also do that for real-time games. You just make smaller turns. Like, okay, if you do FPS, it's not I'm going to go to this place. It's you move a bit. The other guy does that too. You try to find the fun in the paper prototype before having to program. You can also analyze an existing system, like you take a system you like in a game and you try to see, okay, why does it work? You analyze the loops, so that. Even if this analysis is not going to be super professional, which is of course it's not going to be, it's all if you think about it, you try to figure out why something works. That's going to teach you a lot by itself. For programming, the best thing I can tell you to do is to take an engine and follow a tutorial. For instance, GD Quest for Godot is good. Last time we had another developer in the chat in the French class that also gave me a few links, so I'll try to put them into the resources part of the page on the website. So when I'm able to take the time to go back to the recording. And then you have the aesthetics. So this one depends a lot of the field. So I would recommend you experiment a bit at small scale. You do, for instance, if you take a drawing, you take a bit you make a couple drawings. You see how you can manipulate the software. You can see if you can put it into as a sprite into a game or something. But for 2D art, you're gonna take a look at Krita for making some. If you want to make some drawings in general, GIMP is also an option, which I tend to use it more for pixel art myself and photo manipulation. You have Inkscape, which allows you to do vector art, which is more precise. For 3D art, the main option is going to be Blender. It can do a lot of things. And for sound and music, if you want a digital audio workstation, one of them is going to be LMMS, for instance. You have Audacity, if you want to, which is more low level. It allows you to edit the sound waves directly. And BFXR is a small software that allows you to make sound effects, for instance. It's a good introduction. So you might have seen all of those are open source software. So I have a big bias, of course, because I tend to like open source. But on top of that, I also think it's not really super ethical as someone who teaches to teach you something only for something that's proprietary, and that means you'll be locked with that vendor of sorts. Something that's open source is always going to be available for you, and but yeah, and this is what I really recommend and what I will tell you to use. So of course, for instance, in 2D art in proprietary you have Photoshop, which has other tools. In 3D art you have, for instance, Maya, and but in these two cases, well, Photoshop is used a lot, but I found I didn't find a case where I needed some of Photoshop feature. 3D art you had a lot of studios at first that didn't really count on Blender, but the thing is that the tide has changed because the Blender's tools have evolved quite a bit. So now it's more. It's not like you have to use Blender there. No, it's still implementing, but it's more like a lot of productions allow you to use whatever tool you want as long as you get on the same format at the end. You can use Blender, or you can use 3ds Max or Maya. The thing is that Blender is very good for a few things. With the interface change, that means it's not added. It's now a lot more flexible to use, because that was a big problem then, is that Blender had its own interface, and the thing is that for stylized rendering, Blender is the best. There's a whole community on that. But you have a few, and in general it's very good, but you have a few parts that are a bit less good than the others. For instance, For instance, Maya is used a lot because Blender sculpting tools and UV tools are not always the best. So you tend to see some people use the Maya, ZBrush, Marmoset, Marmoset? I'm not sure. A workflow to bake those polygons. And you have and for procedural modeling, Houdini is also very used. Blender has geometry nodes, but it's still somewhat young. For sound and music, this is the part where it usually works a bit less. So glad people like have the so I'm not an expert there, especially like I see Nathan here is recommending LMMS too, so that's good. I'm not sure if Reaper is also one that's open source, but yeah, definitely. I think you have a plugin in LMMS for a BFXer. I definitely need to investigate sound fonts in LMMS more. That's for sure. The thing is that a lot of the sound software is gonna be proprietary. So both on the composition side, for instance, you have Fruity Loops, which is also only on Macintosh, I think, which is going to be a recurring theme for sound. And even in the implementation into games, you often use middleware. And for this, I actually don't know an open source alternative to WWise and which one was the other name? I forgot. Fmod. Fmod and WWise tend to be used a lot in games, so I'm gonna tell you about the concepts, but at this point in time I don't have an alternative in open source. But I mean it just works the same way. But yeah, and of course if you want to do if you don't want to do a field, you have solutions. One of them is to use existing resources. So for instance, Kenny's assets online are available for free. You have a lot of available music and you have music. You have the graphics on, for instance, Open Game Art. You have some people also made templates for games, or you can use specialized engines. We'll talk about that in a bit, depending on what you want to do. I don't recommend using AI for that because you're losing out a lot, even beyond the ethical concerns, because it's current right now. Yeah. You can also adjust your design to limit the problem. For instance, if you're not an artist, you can't do graphics. Well, you can do a game with console graphics. Like the old roguelikes. That's also a way. If you can't make a lot of frames, frames of animation and stuff like that, maybe you want to aim for something that's a bit more static, maybe more focused on systems. That's. But if you don't have someone who can do the art, maybe don't do something that's based on having a lot of image frames, or you have to switch it up a bit. For instance, like I said, with stylized rendering, by changing a bit of the your tools and that, you can try to go around the problem, which is, you can see my blog for how I do that. You can also team up with someone that wants to do the domain. For instance, well, I could find an artist. If if you want to do a small game even here, like on the side of the class, you can talk in Discord and find someone else that's watching the stream that also wants to make a game, and maybe someone wants to do more art and someone wants to do more programming. That's a good way to also to both train the collaboration, but also to focus on the parts you actually like. I do recommend trying out a bit of each, though. That way you can communicate better, and you might not know you enjoy something. That's why I also tell you how to start, because you don't know what you like until you do it for real. So in terms of game engines, so this is gonna be you're most likely gonna use one, and most games use a generalist engine. So of course there's Godot, which is libre and open source, which means it's yours forever, and it has a syntax that's close to Python using GDScript, and it's both simple but also very efficient when you know how to use it, and to use its strengths. And this is my personal recommendation for this project. I think Godot is very good for beginners because it's pretty simple in a lot of aspects, and the programming stays simple. But also for experts, if you really know how to leverage some of the design choices of Godot, it's gonna help you quite a bit. You have Unity, which is proprietary, and you program in C#. So it's a good engine. It's got some very good documentation, and it has a full asset store, so that means you can also Godot has some of that, but not currently at the same point as Unity. That means you can also find a lot of assets and modules already made and available, paid or not. Yeah. So Unity has, well, there was the few issues last year with say some scandals around Unity. So watch out for that. But yeah, it's but overall, when I used it for 6 years before switching to Godot. It was interesting. Each engine has its own vibe, of course. Godot for me works very well because it meshes a lot with the way my brain thinks. Unity's tools, for instance, don't mesh as well with each other, and in the end, I was just ending up recording physics every time, so it wasn't really worth a lot to keep using every one of these tools. But it's still pretty good. A bit hard to finish game with it, from what I've heard, as a consensus. And then you have Unreal, Unreal Engine, which is proprietary. You can code either in Blueprint, which is nodal. Imagine you have node on the screen you have to link together, or C++. And it has some very advanced tools, but it's more focused towards bigger teams. And it has the Unreal way, as I say it. So it tends to work for a specific types of game, which is kind of like the regular AAA game you think of. So it works for FPS, it works for open world, It works very well for games that have some very specific choices. For instance, that you have to control a character. If you do something where you don't control a character in Unreal, it's doable, but it's harder. It wants you to use PBR rendering pipelines, so pretty usual style. So that means, whereas Unity has a lot more customizable rendering pipeline, and Godot has a simple one you can trick it to do it what you want. But Unreal is going to be quite hard if you want to do stylized rendering in it. And it tends to be very good also for bigger teams. Like it is thought for bigger teams first of all. And then you have some specialized engines, for instance, that do focus on a more specific part. For instance, Game Maker is one that doesn't need you to program and is focused on 2D games. You have RPG Maker, you make RPGs. Or as you might have seen more recently, you have a lot of people that do things the other way, that do other types of game with RPG Maker, but that's going a lot beyond what it's supposed to do, and it makes RPGs very well. Like you have all the tools needed already. You have Castaigne, of course. Like it's not exactly an engine, but you can treat it as one. For instance, that allows you to make action games or fighting games, which. And it's the one I made, so of course I'm gonna plug it. But it's also in development, so like it can be useful if you want to dabble in it. But it's think about it before choosing. But yeah, but for instance, it also has a lot of tools to make attacks work directly. Like it has all this state machine and editor to edit those state machines, which if you don't use a generalist engine directly, you're gonna have to make at some point. But this class is gonna assume more of the generalist engine, so that it assumes you have to program that base stuff yourself, and you have to work with it. So I don't recommend you make your own engine, as it's very different and a different type of work. Like when I think about a game, when I think about gameplay, I have to think about how does this part interact with this other part. How can the character reach this point? How is the movement fun? That type of stuff. Whereas if I have to do when you have to make an engine, it's more like how do I store my data in memory? How do I do it in a way that's efficient and runs fast? How can I handle linking to the operating system? How do I have to do all sorts of things? And these are pretty separate from the game itself. So the idea is that it's gonna take a very long time to make an engine, especially now that games are bigger and bigger. And you also have to make the tools that work with it. It's I'm not telling you don't make an engine, but it's usually like you have to know if you're making an engine or a game. That's the thing at one point. So but you can have fun with either. Like if you have fun making game engines and just implementing the tooling for that, well, go ahead. That's very valid. That's just take care that don't think you're going to make a game if you are currently working on the engine. That's very different. Because if you're not wanting to do a lot of programming on the other end, specialized engines can also work pretty well. That's for instance, if you do an RPG, you can use RPG Maker. You can focus on making the graphical assets, for instance. That's why you want to think about it. But I would recommend trying out Godot directly. It's very good. So we're coming to the end. So of course you can. I recommend you join the Discord. That way you can stay up to date. And if you don't have it, I recommend you get the streaming role. Because from now on to avoid pinging everyone every time, I'm gonna just ping the @streaming role. You have the website, which is gonna stay up to date with the coming classes. The next time we're gonna talk about gameplay programming, so it's gonna be on March 3rd, so in 2 weeks. And on the side, I recommend you try out some of the engines and the fields, like I recommended. And you talk with others, think of ideas. So as I said, I recommend taking a tutorial. For instance, GD Quest is good. I've heard like Game From Scratch, Kids Can Code. I've heard of them. I heard they're also good. I unfortunately can't give you my exact opinion because when I started Godot, I was already like 12 years or something into programming. So it's I just read the documentation and went on with it. But depending on when you are at, tutorial can be very helpful. But yeah. So don't hesitate to ask your questions now or even later. But I'm gonna stay a bit more now to answer what you have. Especially this time we have a bit more time, because it's just an introduction class. So I can. So I have some time to answer. Glad you liked it. I hope it's gonna be to your taste. Next time it's so gameplay programming. We're gonna look at more. I'm gonna take a more basic look at what we need. So a bit of programming logic, but also like the underlying things. For instance, here is one of the things I showed this morning for when someone asked me to explain dimensional analysis again. So of course it's gonna be scary like that. But about why do we do our computations that way when we want to make characters move? So it's gonna be a solid theoretical base, I think, for that. So it's gonna be quite helpful. I'm guessing I was so clear there's no questions? So it's not necessarily on the class subject, you can ask general questions. The funny is I'm seeing how fast I go through water today, and well, I drank like 1.5 liters here, so I'm scared for the final classes which are going to be rendering. So I'm probably going to be to have a dry throat that day. So do you foresee difficulties with game finishing with Godot? So Unity. So the problem I heard about Unity's ability to finish games was that it's very easy to start out and to link some systems at first, but it's really hard to make them all work together towards the end when you want to link all of that. So I think I'm not exactly sure. I don't have enough experience in both engines to be able to pinpoint that exactly. Because as I said, I'm been more on the let's make the actual underlying systems. That's what I find fun. Because you have a lot of or small edge cases and stuff like that can creep up very easily, and so Godot has some when I finish games with Godot, usually it's pretty easy because it's usually smaller ones, but it's also I feel it tends to link up a bit more flexibly, and I think it's also because the tools tend to work with each other better. So that's not a scientific remark. That's my opinion and based on feeling. But I feel they work together a lot better. For instance, Unity, if I take the animation system to give an idea of both. So in Unity, the animation system has changed a few times. I think we are the third or fourth since I started. And each time they tend to phase out the old one before the new one is fully ready. And you have to kind of work with it. And sometimes you know that it doesn't really work with the other parts of the engine. You have to make it, to find some workarounds and to have some glue code to make them work together. While Godot's tools tend to be more like, for instance, the animation system here, it's a lot more flexible in how you link it, because the animation system can work pretty easily with animation. You have animation trees, you have the regular animation player, you can add them from code, you can keyframe pretty much any property. Like you can even keyframe the max HP of a character if you want. That's not a good idea, but you can do it. So that allows you a lot more flexibility in how you make solutions. That means you can also find your way out of issues that way. So that's what I like with it. If it's then of course, but it's not the only part of finishing a game, and depending on your team, it can be a bit bigger. So in this area, I'm not super able to give a definitive answer at the present moment. But yeah, I think it's I think for Godot maybe it's optimistic, but I feel it's just gonna be the regular finishing a game problems, which is I got all of these edge cases and I have to make them work. Yeah, good debugging tools help a lot if you can get them early. Yeah, so that's so nobody else has a question. I guess that was a clear class then. Yeah. But yeah, so yeah, I hope you guys enjoyed it. It's the first time I do that in English. No, wait, no, that's not exactly true. That's exactly true because I did it one time before. I have one class that's also in English that you can already find on the on here. It's actually gonna be useful for next time. I linked them to it this morning, so let me give it in the chat here too. Because it's the one I did last year on all of Godot 3's node. It's an advanced topic, a bit of a bonus, but it goes over every node in Godot. I just took the list, I classified it myself, and put the categories where I felt they were the most useful. And there I went, and I explained a bit what kind of features there are, and that also explains a bit where the things go. But yeah. So that's more freestyle, but yeah, I feel you should be able to get something out of it. Oh, one last question: do you have any strong opinion on Godot 4? So if it's in relation to the thing between Godot 3 and 4, I think most of the game logic is gonna go from one to the other without too much issues. I think Godot 4 has a couple of features that are very nice. They did backport a lot of them to Godot 3, so we don't have that much problem. The reason Castaigne is in Godot 3 is because, I started in Godot 3. There's a couple of reasons. One of them is that, the passage to Godot 4 was during development, so I figured it's better if we do that when it's more mature. All of that. And then there's I have put it into the planning at the same time as going to change the language of Castang's core, because because I'm gonna have to make it run faster, and the options in Godot 3 weren't as good as those in Godot 4, which has a lot with the GD extension or native. I tend to forget which one was which, but the Godot 4 has better options there. That way I do the passage together. Godot 4 has some things. For instance, I'm not able to say a lot for the feature because I also haven't been able to run it at the runtime because the AMD drivers on my Linux were broken, so I couldn't really run the thing in Vulkan mode. And one of the things that did change a lot is the rendering engine, actually. This one there's a lot of opinions going around. I haven't been able to investigate it myself yet in detail, but I do intend to do that. And when I say I do intend to do that, I do intend to read the source code and be able to make my own opinion of how it works. And from what I can tell, there's so they did the choice of writing in Vulkan natively. So that's not a positive or negative. Like some people were you have to use this graphics interface, but there's Vulkan also has some ways to port from one graphics API to the other through its modules. It's made for that. It has some there's some choices that are definitely a bit weird if you think about it in the regular rendering context. For instance, the fact that it's a forward renderer. I don't know if it's forward plus yet or not. Maybe just maybe I don't know if it's tiled forward or something, but it's definitely a forward renderer. For instance, whereas a lot of engines use deferred rendering because it tends to be faster with many lights rendering. You have some of the tools that, especially at first, weren't exactly up to industry standard. For instance, I think the occlusion culling wasn't super good, but they did implement it a lot better now. Godot's philosophy in terms of the 3D engine is that it's not so much for the regular PBR super high tech engine. It's the aim of Godot's renderer is to get out of your way. That's the main thing. The idea is Godot's idea is that it tries to stay very welcoming as an engine, and 3D rendering is one of the least parts for the regular users. So if you can not have to think about how all of that works under the hood, it tends to be better. And I think that's a choice I can agree with for the general engine. I agree with that direction. Most people are not going to want to do even AAA photorealistic graphics, so of course, if you want to do that, some tools are gonna be lacking. For my end, my opinion on the renderer, it's probably in the end, I don't know if this is gonna fit me for the opposite direction, because philosophically, Godot's renderer, as I said, it's more you have to get it out of your way. My own requirements with rendering is more. It tends to be very specific, because I have very specific knowledge, and I want to use some algorithms that are very much not standard. Because I have all that bibliography, I can actually work with that. My job is working on graphics engine, so yeah, I can handle that complexity. So I don't know for me how much it will fit, but in terms of engine philosophy, I think that it tends to be a good choice. But then I need to try it out to really see for myself. But from the outside, it looks pretty good. And some people are able to make use of higher rendering techniques. So, but yeah, it's often graphics is also one of the parts where a lot of people don't often have the required experience and knowledge to be able to really share onto it. Even I think me with my it's gonna be 4 years. 4 years working with actual AAA as a graphics programmer, doing that PhD, all of that, and I still think that I have a lot of key blind spots that don't allow me to have a definitive opinion on something, because graphics is just so big. Like, but yeah, but even then, I think my opinion still has some weight behind it because I do know how a lot of that stuff works, and the thing I was able to use the nature of the renderer that's still very simple to do what I wanted to do, even if it was very advanced compared to what others did. So it was nice. So yeah, so no strong opinions on God of 4 yet. Hope that answers your question. Cool. Well, you can use Godot 3 or 4, and no issues on my end. So if you, yeah, cool. I don't know if there's any other questions. Well, I think since it's just you, Tim. Well, no. Well, anyway, everybody. So thank you for coming. I hope you enjoyed the class, and we'll see you. I'll see you on March 3rd, same time, for the next one on gameplay programming. So have a nice weekend. Maybe have a bite to eat depending on the time, or go to sleep if you're in Asia. And see you around then. And bye bye.